Hello, in this video we are going to show how to implement a random forest in the R programming language. We've already spoken about R and we've used it for linear regression and logistic regression and decision trees, and now we're going to expand this into random forest. In this unit we also spoke about gradient boosting, but the gradient boosting packages in R tend to be a little bit more difficult and a little bit less turnkey, so I think that's beyond the scope of what I'm trying to accomplish in these videos. So let's get started. Well, the first thing we're going to have to do is download the R package, the random forest package in R. So to do that, again, as a refresher, you come up here to the packages and you click on that guy, and you have to set the crayon mirror, and the crayon mirror is where you're going to download your files from. So when you click on setting the crayon mirror, this gives you a whole lot of options, and we have to, again, you're sort of asked to choose a mirror that's near you. And so I'm going to go to somewhere near Ohio, and I happen to know that that is Case Western Reserve University, which is not far from me. So I've selected that, and now I have to go over here and I have to install a package, and I'm going to install the random forest package. And they're in alphabetical order. And we look for random forests, and they are there they are right there. So just click on that and it's going to do the installation. Okay. So now what we're going to do is I've written a program already that is going to that we're just going to copy and paste in. So the first thing we're going to do is I'm going to continue. We've already built a decision tree, so I'm going to leave that code in here, and I'm just going to append the random forest to this code. So we're going to first load in our libraries right here, and let's do that right here. And again, you may get some occasional errors where they say that this was built on a previous version or a later version of R. That's usually not anything you need to worry about. And now we're going to load in the same data file that we've been working with up till now. So let's load in those guys. And incidentally, with the random forest, we're going to need this is going to use a random number generator. So we're going to set the seed to the random number generator to 1, 2, 3, 4, 5. And the reason why we're going to do that is it's going to allow us to reproduce the same results over and over again. So if we always set to the same random number seed, we can get the same results. So I'm going to load this stuff in. So we've loaded in the data, and you can see that we've even printed the first 6 records again. Now, here is where we built the decision tree before. So this is what we did in our previous 2 units. So there we're going to build a decision tree. And so there is our decision tree. And if I even do T1 here, you can see that people who have a debt-to-income ratio greater than or equal to 3 have a 91% chance of paying you back and an 8% chance of default. And then you can see that if they have a greater than 3 and less than 45, their chances of default goes from 93 and 6% chance of default. So that's how this works. So let's see here. Now we're gonna bring our random forest in. So the syntax for the random forest is very similar to that of the decision tree. So instead of our part, which stands for recursive partition, we're going to say random forest, and then we simply have to put in importance true and the number of random forest trees. So that's, whereas the tree we had to give a minimum number of buckets, this guy here, we just give them these two options. But otherwise, it's just the same. And the neat thing about the random forest is it tells us also which variables are important. So if I ask for a variable importance plot, the random forest is going to give that to us. So let's see what we get. See, there it does. That's just kind of a neat thing. And even if you're not going to use a random forest for your final model, you can still maybe use this to figure out what variables are important. And you can see that according to the random forest, the most important variable is the debt-to-income ratio, both with model accuracy and Gini coefficient. And the reason why it says mean decrease accuracy and mean decrease in Gini, what that means is this. If I were to, there's two different metrics. If I were to look at the Gini coefficient, if I took this variable out, the Gini coefficient accuracy would drop the most. So this is clearly the most important variable. So according to these two different metrics, the debt-to-income ratio, delinquency, and the value of the house seems to be the first three variables here, and this is debt-to-income ratio, value, and credit line age. So and in fact, if you really look at it, the first 5 variables here and the first 5 variables here are the same. It's just they kind of move around a little bit. So now the next thing we're going to do is we're going to build a rock curve. Now we can do this a couple of different ways. Let's do this. Actually, let's do this 2 ways here. So let's just copy our we're going to copy our training data into a test data set. But in a real world situation, you would have a new data set, but I don't have one, so I'm going to pretend the training and I'm going to copy my training data set into a test data set, and we're just going to use that again. So the first thing we're going to do is predict how the decision tree, we're going to use the decision tree to make predictions. And this is something we've done already, and you can see that if I do head PT1, he's going to print the first 6 predictions. And this command right here, test PT1 equals PT1, I'm going to append these predictions to the test data set. So watch. So I've got all my data here. And I also have the predictions using the decision tree that you are a 0. This gives you, in other words, you don't default on a loan. And this is the predictions that you do default on the loan using the decision tree. So now we're going to do the same thing. And now we're going to make the predictions with the random forest right here. And if I were to do you can see that now I have the tree predictions, and now I have the random forest predictions. So they're both these predictions are there. So now let us see what we do next. Now what we're going to do is we're going to build our rock curves. So what I'm going to do is using the decision tree predictions right here, I'm going to come up with the data that's going to be necessary to build the rock curve. So let's grab that guy. And we're going to do the same thing using the random forest model. We're going to build the data sets necessary for that guy. And now we can build one of 2 lines here. So let's just build a plain old plain Jane vanilla decision tree here. Rock curve. Now I'm going to show you something new that I haven't shown you before. This is how you would put one rock curve, or put 2 rock curves on the same plot. I would do plot and then my data set here, and then if I want another one right on top of the old one, I would do this guy, and then I would have add equals true. So let's just do a real simple rock curve with no colors, no nothing. So let's paste these guys right there, and voila. So this is the rock curve for our random forest, and this is our rock curve for our decision tree. And now if we want to do the same thing with the color, let's do that too. And there you go, the rock curve. And now you can see that the random forest did a great job, and the decision tree not so much. This is a real easy data set, and I think the random forest had an unfair advantage because he built 100 trees and really got to he had a lot of bites at the apple. Random forests are really good, and they many times will defeat a decision tree. Maybe not to this great an extent, but they will tend to be more accurate. However, not always. Sometimes they will overfit. So I just want to say that just because it won in this case does not mean anything. What I recommend always is try lots of techniques. But anyway, so this is the rock curve with some color added. And finally, let's look at the area under the rock curve for the decision tree, and then we'll look at it for the random forest. So the decision tree has an 84% of the area is under the decision tree. And if you are using the random forest, 99%. So it's a really accurate model. So anyways, this is how you would use a random forest in the R programming language. Thank you.